Astronomers thought supermassive black holes took at least 1 billion years to grow. Not 1 billion, 0.4. Right now, 13.2 billion light years away, NASA has spotted a giant black hole that should not exist yet. It is so huge that it breaks every rule we have ever written about how the universe built its first giant objects. If you love uncovering real space mysteries before they make it into school textbooks, hit that subscribe button right now. We dig into actual NASA data every week so you can stay ahead of the cosmos. Join our growing community of stargazers today. To understand why this new discovery sent shockwaves through the scientific world, we have to start with how we thought black holes worked. For decades, every astronomy textbook taught the exact same story. When a massive star runs out of fuel at the end of its life, it collapses under its own gravity. The core shrinks down into an infinitely dense point, creating a standard black hole that weighs about 10 to 20 times more than our sun. That sounds big, but in cosmic terms, it is just a tiny seed. From that small starting point, a black hole is supposed to grow very slowly. It acts like a cosmic vacuum cleaner, pulling in nearby dust, gas, and stray stars over millions of years. As it eats this material, it gradually gains weight and gets bigger. If two galaxies collide, their central black holes might eventually merge together, combining their mass into an even larger object. Scientists calculated that building a supermassive black hole, one that weighs millions or billions of times more than our sun, should take a tremendous amount of time. Our own galaxy, the Milky Way, has a supermassive black hole at its center called Sagittarius A star. It weighs about 4 million times the mass of our sun, which sounds gigantic until you realize how long the galaxy has been around. The Milky Way had over 13 billion years to feed its central black hole and help it grow. Scientists assumed that if you looked back to the very beginning of time, you would only find small baby black holes. They believed the universe simply was not old enough to have produced giant cosmic monsters yet. The universe itself started with the Big Bang roughly 13.8 billion years ago. In the beginning, there were no stars, no planets, and no galaxies at all. Everything was just a hot, smooth soup of hydrogen and helium gas. It took about 100 million years for that gas to cool down enough for gravity to pull it into the very first stars. These first stars were huge and bright, but they lived short lives before exploding and leaving behind the very first baby black holes. According to standard physics, growing one of these baby black holes into a supermassive monster takes time because black holes are actually very messy eaters. When gas falls toward a black hole, it speeds up and heats up due to friction, glowing brilliantly with radiation. That radiation creates outward pressure, pushing away any extra gas that tries to fall in too quickly. This natural speed limit is known as the Eddington limit, and it stops a black hole from eating infinitely fast. Because of this physical speed limit, computer models predicted a clear timeline for the history of space. A baby black hole formed shortly after the Big Bang could only double its size every 40 million years or so. Even if it ate constantly without stopping for a single second, it would still need at least 800 million to 1 billion years to reach the size of a supermassive black hole. That was the law of astrophysics, and almost every astronomer on Earth agreed on it. For a long time, we did not have the technology to test whether this timeline was actually true. NASA relied heavily on the famous Hubble Space Telescope to look deep into the distant universe. Because light takes time to travel across space, looking at objects billions of light years away is literally looking back in time. When Hubble looked at distant galaxies, it was seeing them as they appeared billions of years ago. But Hubble mostly saw visible light, which gets blocked and scattered by cosmic dust clouds, making it hard to see the earliest objects clearly. Hubble gave us incredible images of the Middle Ages of the universe, showing galaxies that were already billions of years old. In those mature galaxies, supermassive black holes were common and expected. But scientists wanted to look even further back, into the cosmic dawn when the very first galaxies were forming. They wanted to prove that early black holes really were tiny baby seeds, just as their computer models predicted. Did you know that gravity can actually set a speed limit on how fast matter can fall into a black hole? If this fact surprised you, hit the like button and drop a comment below telling us if you thought black holes could eat endlessly. Don't forget to subscribe so you never miss another mind-bending space fact. To see back to the cosmic dawn, NASA knew they needed a completely new kind of space telescope. They spent over 2 decades and $10 billion designing and building the James Webb Space Telescope, often called JWST. Unlike Hubble, JWST was built to detect infrared light, which is heat radiation that can pass right through thick cosmic dust clouds. Infrared light is crucial because as the universe expands, light traveling across billions of light years gets stretched out into longer, redder wavelengths. JWST was launched into space on Christmas Day in 2021, traveling 1 million miles away from Earth to a special point in space called Lagrange Point 2. Equipped with a massive gold-plated mirror over 21 feet wide and super-sensitive cold instruments, JWST could pick up the faintest whispers of light from the very first galaxies. Scientists expected JWST to confirm their theories by finding small, faint galaxies containing tiny baby black holes that were just beginning their long growth process. Instead, almost as soon as JWST turned its golden mirrors toward the edge of the observable universe, it found something that defied explanation. In 2023, astronomers pointed JWST at a super-distant galaxy, known by the designation UHZ1. By analyzing the light from UHZ1, they calculated that we are seeing this galaxy as it existed just 470 million years after the Big Bang. That means the universe was only 3% of its current age when this light left the galaxy. Scientists expected UHZ1 to be a modest infant galaxy with a tiny central black hole weighing perhaps a few thousand suns. But when they combined JWST's infrared images with X-ray data from NASA's Chandra X-ray Observatory, the results made researchers double-check their calculations. Chandra detected intense energetic X-rays pouring out from the heart of UHZ1. These high-energy X-rays are the classic signature of an actively feeding supermassive black hole. Here is the mind-blowing detail that scientists are still arguing about in laboratory hallways today. The black hole at the center of UHZ1 is not a tiny baby seed at all. It is a fully grown supermassive monster weighing between 10 million and 100 million times the mass of our Sun. Finding a black hole this massive just 470 million years after the Big Bang is like walking into a kindergarten classroom and finding a child who is 6 feet tall and weighs 200 pounds. The existence of this giant black hole so early in time completely shatters the theoretical timeline. If you start with a normal stellar black hole formed by the death of a star, there simply was not enough time between the Big Bang and UHZ1 for that black hole to grow to tens of millions of solar masses. Even if it ate gas at its absolute maximum theoretical speed limit without taking a single break, it could not have reached that size so quickly. The math simply does not work. To make matters even stranger, researchers looked at the ratio between the weight of the black hole and the weight of all the stars in galaxy UHZ1. In modern galaxies like our Milky Way, the central supermassive black hole makes up about 0.1% of the galaxy's total mass. The stars weigh thousands of times more than the black hole at the center. But in UHZ1, the black hole weighs roughly as much as all the stars in the entire galaxy combined. Imagine living in a house where the front door key weighs as much as the whole house itself. That is the kind of bizarre, cosmic balance scientists found in galaxy UHZ1. It is an oversized black hole sitting inside an undersized galaxy, completely flipping our understanding of how galaxies and black holes grow up together. NASA scientists realized immediately that they were looking at a completely different kind of cosmic evolution than anything they had imagined. When you picture a galaxy, do you usually imagine the stars forming first or the black hole forming first? Tell us what your intuition says in the comments right now, and smash that like button if this discovery is blowing your mind. Subscribe today to join our community of curious minds exploring the universe together. To solve this giant mystery, astrophysicists had to go back to the drawing board and question their most basic assumptions. How could a black hole reach tens of millions of solar masses in such a short amount of time? Broadly speaking, scientists have proposed two main competing theories, often referred to as the light seed theory and the heavy seed theory. Each theory paints a dramatically different picture of what the early universe looked like. The light seed theory tries to keep the traditional model intact by making one extreme change. It suggests that black holes really did start out small, from the collapse of the universe's very first giant stars, known as population 3 stars. These ancient stars were made purely of hydrogen and helium and could grow hundreds of times larger than our sun. When they exploded, they left behind light seeds, black holes weighing roughly 100 solar masses. However, for a light seed to become the monster in galaxy UHZ1 in just 470 million years, it would have to break the cosmic eating speed limit. It would need to undergo what scientists call super-Eddington accretion. This means the black hole somehow swallowed gas at a rate 10, 20, or even 50 times faster than the theoretical limit without blowing away its food supply with radiation pressure. It would be like a person stuffing down thousands of meals a day without ever getting full or choking. The alternative explanation is the heavy seed theory, also known as the direct collapse black hole model. This theory proposes something far more radical and dramatic. Instead of starting from a dying star, a heavy seed forms when an enormous cloud of pristine gas collapses directly into a black hole all at once. Imagine a giant cloud of gas containing 10,000 to 100,000 times the mass of our sun floating in the early universe. Normally, as a gas cloud shrinks under gravity, it cools down and breaks apart into smaller clumps that form individual stars. But if the cloud is kept warm, perhaps by intense ultraviolet light from nearby young galaxies, It cannot cool down or fragment into stars. Instead, the entire massive cloud keeps shrinking as one giant unit. Eventually, the center of the cloud becomes so dense that gravity wins completely, collapsing the cloud directly into a heavy black hole seed in one single violent event. Now pay close attention, because this next part changes everything we thought we knew about cosmic history. If heavy seeds really exist, a black hole does not need millions of years of slow feeding to get started. It gets born as a giant wing tens of thousands or even hundreds of thousands of suns right from day one. From that massive starting point, reaching tens of millions of solar masses by the time of galaxy UHZ1 becomes much easier to explain. The discovery in galaxy UHZ1 provides the strongest evidence ever found that heavy seed black holes are real. For years, direct collapse black holes were just an interesting mathematical idea, written on blackboards by theoretical physicists. Many scientists doubted they could actually form in the real universe because the conditions required were so specific and rare. But JWST and Chandra have shown us that nature found a way to make them happen on a huge scale. Shortly after the UHZ1 finding, JWST spotted another bizarre early object named LID 568. This object is a supermassive black hole seen as it was about 1.5 billion years after the Big Bang. When scientists measured LID 568, they found that it was swallowing gas at over 40 times its theoretical Eddington limit. This proved that early black holes were not just born big through direct collapse, they were also binge-eating at insane speeds whenever food was nearby. If you had to choose between a black hole swallowing gas 40 times faster than normal, or a giant gas cloud collapsing all at once, which idea sounds cooler to you? Drop your vote in the comment section below. If you are enjoying this deep dive into real space discoveries, make sure to give this video a like and subscribe for more. These combined discoveries have forced scientists to confront an even bigger question. What came first? The galaxy or the black hole? For decades, the standard assumption was that galaxies were the primary structures of the universe. Gravity-gathered gas, stars formed by the billions, and over time, matter collected at the dense center of the galaxy to feed a growing black hole. In this view, black holes were just interesting extra features born inside existing galaxies. But the new data from JWST is suggesting that the universe might have worked completely backwards. If heavy black hole seeds formed directly from gas clouds before most stars were even born, then the black holes came first. A giant black hole would form in empty space, and its immense gravitational pull would start dragging in surrounding gas from millions of light years around. That pulled-in gas would eventually cool down and ignite into the first generation of stars, building a galaxy around the black hole. In other words, supermassive black holes might not be the children of galaxies at all. They might be the seeds or parents that created the galaxies in the first place. Without these ancient gravity anchors pulling matter together at the dawn of time, gas clouds might have taken much longer to gather into galaxies, drastically changing how the entire universe evolved. This realization turns our standard picture of cosmic history upside down. This discovery also changes how we think about dark matter in the early universe. Dark matter is an invisible substance that makes up about 85% of all matter in space. We cannot see it directly, but we know it exists because its gravity pulls on normal matter like stars and gas. Scientists suspect that giant halos of dark matter formed first in the early universe, creating deep gravitational pits where pristine gas could collect and collapse into heavy black hole seeds. If you think that sounds wild, wait until you hear what NASA's computer simulations showed when they tried to recreate this event. Scientists ran massive supercomputer simulations at NASA Ames Research Center and Goddard Space Flight Center to test whether standard physics equations could reproduce what JWST saw. In simulation after simulation, the virtual universe failed to produce black holes as large as the one in UHZ1 within 470 million years, unless they tweaked the simulated laws of thermodynamics and gas cooling. The supercomputers were essentially telling researchers that our current models are missing key pieces of physical reality. Either we do not fully understand how gas cooled down in the early universe, or there were extra processes occurring during the cosmic dawn that we have not accounted for yet. Some theoretical physicists are even suggesting that exotic particles or strange magnetic fields in the early cosmos helped crush gas clouds faster than previously thought possible. Do you think there are fundamental laws of physics that humans have not discovered yet? Share your thoughts in the comments section right now. We read every comment, and your ideas help spark awesome discussions. Be sure to subscribe and hit that bell button so you are notified every time we release a new investigation. Shift your focus now from what happened in the past to what is happening right now in space research. Today, as you listen to this, astronomers around the world are rushing to re-examine thousands of early universe galaxies captured in JWST's massive image archives. Teams of researchers are competing to find even more distant black holes, searching through faint red dots in the deep field images to see if UHZ1 was an isolated freak event or part of a common pattern. Every new observation coming in from JWST is adding fuel to this scientific revolution. Astronomers are combining JWST's infrared spectra with radio observations from the Atacama Large Millimeter/Submillimeter Array, or ALMA, located high in the mountains of Chile. ALMA can measure the coal, dust, and gas surrounding these infant galaxies, giving scientists a complete picture of how much food is available for these monster black holes to eat. Furthermore, upcoming space missions are preparing to join the search. The European Space Agency's Euclid telescope, which launched recently, is mapping huge areas of the sky to find rare, bright objects from the cosmic dawn. NASA is also preparing the Nancy Grace Roman Space Telescope for launch later this decade. Roman will have a field of view 100 times larger than Hubble, allowing it to sweep across vast swaths of space and spot thousands of early galaxies for JWST to inspect in detail. This active hunt raises intriguing questions about what else might be lurking out there in the cosmos. If giant, heavy seeds were common in the early universe, what happened to the ones that never found enough galaxy material to build a full home around themselves? Could there be massive, naked black holes wandering through the empty voids between galaxies, left over from the dawn of time? Scientists are also looking closer to home to see if remnants of this early era exist in our own astronomical backyard. Astronomers are searching dwarf galaxies and globular star clusters near the Milky Way for intermediate mass black holes. These medium-sized black holes, weighing thousands of times the mass of the Sun, could be leftover heavy seeds that never got the chance to grow into full supermassive monsters. Finding one nearby would give us a living fossil from the cosmic dawn right in our neighborhood. Here's the twist that makes top astrophysicists stay up until 3 in the morning. Some researchers are asking whether some of these early black holes could be primordial black holes formed not from gas clouds, but directly from dense pockets of energy created during the Big Bang itself. If primordial black holes exist, they could potentially explain both the early monster black holes and even the mysterious dark matter that holds galaxies together today. What do you think is hiding in the deepest corners of space that we haven't found yet? Tell us your favorite theory in the comments below, and don't forget to like this video. If you want to keep exploring these mysteries with us every week, make sure you are subscribed with all notifications turned on. When we talk about giant black holes 13 billion light years away, it can be easy to feel like none of this matters to our daily lives on Earth. After all, a black hole in a distant galaxy called UHZ1 cannot pull us in, and its radiation will never reach Earth in harmful amounts. But when you zoom out and look at the big picture, this discovery connects directly to our very existence as human beings sitting on a rocky planet today. We are made of atoms like carbon, oxygen, nitrogen, and iron. None of those atoms existed right after the Big Bang. The early universe only contained hydrogen and helium. Every heavier element in your body, from the calcium in your bones to the iron in your blood, was cooked inside the nuclear furnaces of ancient stars that lived and died billions of years ago. Those stars were able to form because gravity pulled gas together into galaxies. And, as we are now learning, those galaxies were shaped, seeded, and structured by supermassive black holes that formed faster than anyone thought possible. Black holes act as the ultimate thermostats of the universe. As they feed, they blast powerful jets of energy back into space, heating up surrounding gas and controlling how fast new stars can form. Without black holes regulating galaxy growth, gas might have collapsed too quickly or blown away entirely, preventing stable solar systems like ours from ever forming. In a very real sense, we exist because black holes played their crucial role at the dawn of time. Understanding how supermassive black holes form so quickly is not just an abstract math puzzle for scientists in white coats. It is the story of our cosmic origins. It is the story of how a smooth, boring cloud of gas turned into a vibrant universe full of stars, planets, liquid water, and intelligent life capable of building space telescopes to look back at where it all began. NASA's discovery in galaxy UHZ1 reminds us that the universe is still full of surprises. Just when we think we have written down all the rules and figured out how nature works, a new telescope opens its eyes and shows us that reality is far grander, stranger, and more exciting than our wildest theories. Science is not a finished book of facts. It is an ongoing adventure where every answer opens up 10 new questions waiting to be explored. If you enjoyed this deep dive into one of NASA's most surprising discoveries, please take a second to hit that subscribe button right now. Make sure to turn on the notification bell so you never miss an episode when new space data drops. We would love to hear your thoughts, so leave a comment below answering this question. Do you think black holes are the true architects of our universe? And if you have a friend who loves space, share this video with them so they can join the conversation too. Thank you so much for watching, and keep looking up at the stars.